All right. So in the meantime, perhaps you could invite some other students, perhaps, Bart?
Yeah,
and we can see if others could join as well.
Yeah, I'm sorry.
Okay, very welcome everybody to this new course, the data science course. I've already met a few of you guys already. For all of the other ones, I'm a new face, perhaps, in this master next level engineering. I have a lot of information to cover in this 1.5 hour. Well, actually, we already are 50 minutes later than expected. Unfortunately, due to the striking of the public transportation. Perhaps I could skip the, because I would like to know each other a little bit more, and also a little bit of your background, but perhaps we can do that when we see each other live next week. I don't know if there will be strikings on Thursday as well, but we will see. So I'll skip that for the moment to gain some time to tell you everything about this specific course, the data science course. So welcome again. I don't know if I should introduce Bart. You've seen Bart already in the last couple of courses, at least for engineering fundamentals, I presume.
Yeah, but I think they probably forgot, because this is a little bit new slide for them as well. Probably.
Oh, okay. Well, so maybe you could shortly tell a little bit about yourself, Bart.
Yeah, so this is what I did on university. I designed a new transistor. And the nice thing is that I combined it with a model of the transistor, a quantum mechanical model of the transistor. And I got a rather high grade. And the reason was that I did the modeling in my spare time together with my thesis. And in the end, I could use it a lot for those theses. And also at that time already, this is a long time ago, it's really long time. Yeah. I did an assignment with a neural network.
Okay.
But at that time, it was still very bad.
Yeah.
So it was before the big revolution.
But it was in the winter of artificial intelligence.
Yeah.
Yes.
But it already had my interest. Okay. Next one. Yeah, this is me, being a first project leader. And after that, department manager, and mainly in research. And it's all research projects. Also in Korea, this is a famous Korean dish, bibimbap. I lived there for a 2 times, half a year. Alcatel, hated that job. Sales was not fun at all. Yokogawa, that was quite nice job. R&D manager for sensors. And then 11 years ago, I went to the HU. Did a lot of development of new courses. That's this animation.
All right.
And actually, this last job is the best job I ever had. It's really fun here. So.
Okay.
Oh, and I wrote a book, but that's
all right.
Common knowledge, I think.
Okay, Bart. Thank you very much. Let me introduce myself as well. My name is Johan Loinga. In the origin, I studied computer sciences on the University of Twente. I've also studied civil engineering as well. And I started with a company called Ericsson, active in mobile communications. I was in marketing and sales for about 10 years. I lived a couple of years in Sweden, worked in the United States for some time. I think this is one of our sites in San Francisco. Worked together with Peg Bell over there. It was a fun time, very international. Then after that, I started my own company together with an ex-employee of Ericsson as well. It's called Mobillion. We were active in mobile communications, especially the first start of, let's say, smartphones and iMode together with the Japanese operators and so on. So that was fun. After that, I worked a number of years in the management group of the Sky Radio Group in the Netherlands, and I was responsible for the IT over there as well as for the studios over there. I also started with doing lectures at the Conservatory of Amsterdam, which I still do, teaching sound design. So that's also what I do And 6 years ago, I started at the Hogeschool Utrecht to do lectures for technische bedrijfskunde, or say industrial engineering, here at the University of Applied Sciences here. And I started this course about 3 years ago in data science and artificial intelligence. Okay, so what I would like to do is like to skip this one. I think it would be better because I'm still interested to hear from you guys what your background is, especially if you have any experience with programming, because we are going to do a lot of programming here. But let's skip that for next week. So then let's meet each other in live. That makes it a little bit easier, I think. Okay, what are we going to do today? I would like to tell you a little bit about, okay, what is this course about? This is about data science. So what are the objectives of this course, and what should the outcome be, and what are the things that you are supposed to do, either in groups or individual. And I would like to make a head start with data science in general. What is data science? You know, we have a lot of different words for having computers to do modeling and to do predictions and so on. So we talk about artificial intelligence, we talk about data science, we talk about big data, business intelligence, business analytics, and so on. So I'd like to clear up that cloud a little bit on what we mean with data science, and also show you a little bit about the applications, typical applications in businesses. What do companies do with data science? What do they do with artificial intelligence these days? Okay, and that shines a light upon, okay, what are the most interesting topics within AI, artificial intelligence, or data science that companies are working with at the moment. And maybe you can start working with that one later on as well, when you finish the Master Next Level Engineering. Okay, so what is the goal of this data science course within the Master Next Level Engineering? Well, that is at least to explain what is artificial intelligence, what is data science, what is machine learning, and so on. What we do in this course is that we are going to work with data, lots of data. And to work with data, you have to, collect it first. You have to clean it before you can start making models out of that data. And what we do, we use that data to make predictions for the future. And these predictions can be made by using various machine learning tools. And we're going to do a lot of programming around it. Another thing which is important is to create data visualizations of your data and of your outcomes. So that's also an important topic that we're going to go through. And then, how to apply then machine learning methods, all of these methods in the real world. What can you do with it, and how does it work? So that's the quick summary of what the goal is of this data science course. By the way, if you have any questions, let me know, or put your questions in the chat, and Bart will monitor it here, and then I'll dive into that one. So how does the course look like? Well, we will do this course with myself as well as Bart. So we are going to take turns with a number of lectures in the coming weeks. We also have some guest speakers that we have invited to tell their story. Okay, how do they apply data science, and how do they apply artificial intelligence in practice? How does it work? So that will be around week 6 or week 7 or something like that. After that, you've had some background on what data science is and how it works, that you are able to fire off some interesting questions, I hope, to these people. We'll have practical sessions to work with the different methods and algorithms. And you also have to work in groups in order to do a group report, and that will be evaluated at the end of this course. So how does the course look like? Well, we have 8 weeks, the coming 8 weeks, or rather 9 weeks, because we have an extra free week in between. We have 2 sessions every week on Monday and on Tuesday. Monday at 1300 hours and Tuesdays at 10 o'clock. And after these 8-9 weeks, the idea is that you should hand in a group report. You should work together with a number of other students. The due date for the report is April 6th. Besides the group report, you will also have an individual assessment, and that will take place either on April 11th or April 13th. So book those dates and make sure that you're available. I think it's in the Rooster as well. And the resit, if you have to do a resit, will take place in May. Okay, so here you have the weekly schedule. As you can see, we have these 8 weeks with 1 week in between the spring break. And we have sessions at Monday and as well as on Thursday. The idea is that on Monday we will go through a lot of theory. So it will be mostly a one-way traffic from us to you guys to tell everything about the different methods and algorithms and so on, what they do. And on Thursdays, we're going to do the practical bit. So there we're going to do exercises and go through code and explain and so on. So that's where we do the work and the preparation. And in between, of course, you should devote some time with your group to do the group report. So now we are here. And on Thursday this week, I have a lot of information for you as well about the data mining process and about the different tools that we are going to use. And from then on, we are starting to look at the different libraries for Python. We're going to look at visualization. And then from week 3 and on, we are going to go through all of the different algorithms and methods that we that you can use in data science or in machine learning rather. Which includes building neural networks and also have a look at generative neural networks, which is becoming very popular these days to generate pictures and text and so on and predict those ones. Yes. So that's the program. The material that you should use or could use, it's not mandatory, but it's recommended, are these 4 books. And I should say, especially the last one, the hands-on machine learning, is actually the one that explains most of the things that we are going to do. And all of the other 3 books are more for introduction in Python, introduction into statistics, and into general concepts rather. So my personal recommendation is to at least have a look at the hands-on machine learning, scikit-learn and TensorFlow book, because that's what we're going to use mostly in this course.
Yeah, it's a really nice, readable book.
Yeah, and it's very, it's rather thick, a lot of information. I don't know if you can, I have it here in the camera. It's rather, it's quite a lot of pages. We're not going to do everything here, but it's about 800 pages, and especially, let's say, half of the book. More or less, in the beginning until half the book. That's the part that we are going to go through in this course.
But it doesn't feel like 800 pages. That reads really easy and
it's quite applied. So it will show you how to set up, let's say, also the programming for doing the calculations and doing the modeling and so on. So it's very hands-on. Okay, so there is some prior knowledge needed in order to start with data science. At least some basic Python program is needed, some basic knowledge perhaps of linear algebra, and also some basic knowledge about statistics and distributions would be very welcome. If you think that you're lacking some of these knowledges or some of these then have a look at, for example, Data Science from Scratch book. Chapter 1 to 7 that will address Python, let's say starting to program in Python, but also addresses some statistics and distribution theory. So that would be good. And there's a lot of other information because on the internet you can find a lot of things about data science and also courses and videos and so on. So there is a lot of information that you can have a look at. So what are then the tools that we're going to use in this course? Well, for data collection, we will, or you could use the web scraper extension. It's an extension at the Chrome browser from Google. And with that one, it makes you a little bit easier to scrape some data from the internet. There are some more sophisticated Python libraries that can do the stuff, but that will take a little bit more time. I will tell a little bit more about it on Thursday. Excel might come in handy because we're mostly going to work with tabular type of data, and it is not, well, in some cases you might even have problems to load all of the data in Excel because it's limited in size. But for smaller type of data that could come in very handy. Concerning the development environment, you can make a decision yourself. You could either use the Spider. I think you worked with Spider before for Python programming on your laptop. It's part of the Anaconda distribution set. But you can also work in Colab, and I'll show you on Thursday how Colab works. It's from Google. It will allow you to run the Python scripts and the machine learning in the cloud. And the advantage is that you can switch on graphical processing units, which will make especially the neural network modeling a lot quicker. So when we're doing the neural networking and building models from that, I think Colab would be better because that will give you all the power of the cloud and the GPUs, or the let's say the faster processing units in order to do all the calculations needed.
And also the way Colab handles comments, I think it's nicer than Spider.
Right.
That you can have like real text and formatted text within your program.
Right.
That's pretty cool.
Yeah.
You can put formulas in your program. That's pretty cool.
Yeah. It uses the IPython type of, let's say, divisions between code and comments and so on, and you can mix and match those and start very easily separate out code, for example, and start pieces of code separately and so on. So I'm going to use mostly Colab also for the exercises. So I would like to recommend you to do so as well.
I'm going to do the same. Eh?
Yeah, and Bart is going to do the same. So we'll make the switch to Colab, I think, for this course. When it comes to programming, obviously Python is the main programming tool that we're going to use. But there are a number of libraries that we are going to use extensively, and not only NumPy. I think you've already worked with NumPy, but we're going to use with Pandas, which is the default library for machine learning. Pandas is more or less comparable with making tables in Excel, changing around columns, changing around rows, and so on. It's dedicated towards not only numerical type of data, but also text data and all kinds of other types of data that you could have in tables. Also scikit-learn, which is let's say the machine learning package in Python, but also for visualizations, we're going to use obviously Matplotlib, but also extensions from it, like Seaborn, which are powerful extensions based on Matplotlib. It makes it easy to do quick visualizations on your data. And last but not least, for building neural networks, we're going to use with Google TensorFlow version 2. And with that one, we're going to build neural networks, different type of neural networks, not only the basic networks like the perceptron networks, we will explain what that is, but also convolutional neural networks, recurrent neural networks, but also the generative adversarial networks for generating pictures, for example. Okay, again here, a lot of free data science resources are available also with a lot of background information. And here you have some examples of sites where you could find a lot of, let's say, data or data sets, but also background information, how to do things and so on. So I recommend you to have a look at that one as well. Okay, everything about this course is also on Canvas, obviously. So there you will have the overview of the different courses. You will have the overview of the course material and also the assessments and yeah, all of the detailed information is over there. So what do we expect from you guys to complete this course? Well, actually two things. First of all is to complete the group assignment. And the idea is that you should form groups consisting of 3 to 4 students. And you should find a topic for it, and a typical data science topic where you try to predict something based on a lot of data, or or combinations of data. That's one thing. And the other thing is that we will do individual interviews or assessments with each of you guys, and it will take around 15 to 20 minutes. And in those interviews, we're going to ask you about not only your contribution in the group, but also especially, some theoretical background. Why did you choose this method? How does this method work? Can you explain what supervised learning is? Can you explain what a generative adversarial network is, and so on and so on?
Can I comment a little bit on that?
Yep.
What you experience with engineering fundamentals is that basically if you were allowed to go to the assessment, then you already knew that you would make it, right? That's for this course a little bit different. So you really have to prove in that assessment that you also know the theoretical background. And it's so that's different. So really prepare yourself well for that assessment. It's really different than for engineering fundamentals.
Yes. So we don't have a filtering beforehand. You should enter into the interview and people dive into both the theory as well as the work that you've done inside the group.
Yeah, because last time, for instance, you had research for the assessment only also, right?
Yes, I think last time we had about 30 students, I think, and we had about 4 resits, to give you an idea. Okay. So again, one part is the assignment, is the drawing up a report in groups of 3 to 4 students. That can be initiated by yourselves or to come up with a subject. But you have to hand in a proposal to us, and we will approve your proposal or give comments and so on this one. And this is a process that we would like to finish either this week or next week. On Thursday, I'm going to tell you a little bit more about some of the group work that students did last year and the years before, to give you an idea of, what kind of subjects are possible. So that will give you an idea, and hopefully by next week, somewhere in next week, you will be able to find a subject for yourself and form groups with other students. Okay. So the grading, the group report will count 50% of your final grade, and the individual assessments will also count for 50% in your final grade. You have to have a 5.5 at least for both parts, both for the group assignment as well as for the individual assessments in order to pass the course. If you fail in one of 2, then you have to do the resit for it. Okay. Okay, I think I'm going to skip this one given the time. I will tell a little bit more about these assignments on Thursday and also give you a number of examples so that you get an idea, what is the kind of assignment that we could pick and what is suitable for this course. Okay, so skip this for the moment. I'll tell you a little bit more about it on Thursday. Okay, so far about the data science course and the structure and the way that we have set up things. Are there any questions so far about the course itself and the setup? Is it all clear for everybody? How many students do we have?
14.
14.
So
okay.
we're pretty full.
Almost complete. Okay. Yeah. So I don't hear anything, so I presume that everything is clear so far, given the course structure and what to do. Is that correct? Yes. All right. So let me then start with the introduction in data science. What is then data science, and what are the typical applications that we see nowadays around data science in businesses? Data science is a very broad, let's say, it has a very broad scope. There are a lot of different, let's say, type of explanations on data science, but in general, people agree that we're talking about a set of principles or algorithms or processes to find patterns in-large data set. So if we have a lot of data, then data science techniques can help us to try to find certain patterns in this data. And these patterns can help us to either distinguish certain data from one another, or can help us to predict something for the future. If we get more data, okay, what can we say then about that data? And can we use that data to predict the future? So this is quite a booming area, data science. Any idea why this is booming at the moment, data science? Do you guys have any idea?
You can turn on your mic.
Well, because of the internet, I would say. There's so much data to see, and you can make everything more efficient with it if you analyze it well enough, I would say.
Right. So one aspect indeed is, that was Alexander, right? Yeah. Yes, Alexander, you're completely right. We have a lot of data. There is a lot of data, and you know that every day, also on YouTube and so on, the amount of data that is generated is enormous. So there is a lot of data, and companies are collecting more and more data on what's happening within their company, but also collecting data what's happening outside of their company. So, for example, nowadays, companies, when they have a large dependency on online business, for example, they register every move that end users make. So they track all the mouse clicks, they track all the pages that people visited, and so on, and that generates a lot of data. And from that data, obviously, you can try to predict, okay, what do end users do? Can we do certain recommendations for them, and so on. And also in industrial companies, in production, we measure more and more what's going on. We call that Industry 4.0, for example. We have things like Internet of Things, for example. We have a lot more sensors that are generating all kinds of data. And we keep track of that data in order to learn from what's going on, right? So yes, we have a lot of data. So that's one important factor why data science has become more popular as a topic. Any other developments why data science has become more popular these days?
Maybe also because AI is getting more and more popular.
Yeah, and what's the reason for it getting popular?
Yeah, I think because it becomes better because of data science. And for more purposes, more useful.
You say it's becoming better. You mean the methods and algorithms are getting better, perhaps?
Yeah.
Is that what you mean?
Yeah.
Yeah. Well, that's true. We had a so-called artificial intelligence winter or machine learning winter, let's say 20 years ago. And about 10 years ago, we had some breakthrough, let's say, developments, both in research as well as in applications, for example, driven by Google with AlphaGo to try to beat the top the world player playing the game of Go. It was a very difficult game. So yeah, using machine learning, the computer was able to beat this top player. So yes, we have seen a lot of new developments here in algorithms and techniques around artificial intelligence. And maybe you know about one of the latest developments. This is about natural language processing, the GPT type of developments that we've seen. The Chat GPT.
Everybody's smiling.
Yeah,
not everybody, but yeah.
We're going to, in this course, I will tell you about how it works and how you can program something basic yourself in that way, how things are set up. So we're coming back on that one. So yeah, techniques and algorithms have become better. But there's one important thing that I haven't heard yet, why data science has become booming, why all this is possible.
The hardware is capable.
Yeah. Computers, processor capacity, cloud capacity. Yeah? So yes, there's a lot more computer power and capacity available. Processor power has become much more powerful in the last, and especially when you bundle those things up in a cloud environment, you have a lot more computer power at hand to build these models that you need to for artificial intelligence and that you need to predict, right? So that's a very important development, the processing power and the use of cloud technology. Okay. So yeah, then a lot of buzzwords in this area. Let's start with data science. I have here in the red square, I have all the things that belong to data science. So what is data science? Again, it's a set of algorithms, principles for detecting patterns in data. And on the top, you can see the green circles. Those are the things that businesses often use. In companies, we're often talking about business intelligence and business analytics. And intelligence is mostly about the past, what has happened in the past. And business analytics is more trying to predict the future. And part of data science is also machine learning. And I'll come back to that one in a minute. But machine learning is the technique for having a computer to learn from data. And I'll explain to you how that works. And in order to learn, you can do that in different ways. And one of the ways of doing this is to use neural networks for this. So neural networking is, again, a part of machine learning. And neural networks will allow you to, let's say, make complex models and do things like ChatGPT, for example. So that's data science. And then we have something like artificial intelligence. And it's obviously related to data science, but artificial intelligence is more a broad term, you could say. And this is about intelligence displayed by machines. So how could we have a system to do things that normally humans only could do? And that involves studying the brain and how the brain works. And that doesn't not only involve computer science, but it also involves things like psychology and also philosophy in some ways. Yeah. So if you study artificial intelligence, that will be more broad. And computer science and machine learning will only be a part of that one. Yeah. So further in this course, we are going to zoom in on specifically machine learning, and also we're going to look at and program neural networks. And we call that deep learning. And I'll tell you where this term deep learning comes from and what does it mean deep, right? So back to data science. So what are the most common data science tasks that we see? What can you do with data science? Well, first of all, we can predict things. And you can split it up actually in two areas. That is, predict a class, like, okay, do we see a picture of a cat or do we see a picture of a dog? Then you try to predict a class. It's either a cat or it's a dog, right? You can also try to predict a number. For example, given a number of features, a number of, let's say, arguments for, let's say, houses on Funda. In the Netherlands, we have a site called Funda. You see all the houses over there. They have a number of, let's say, how do you call it? They have a number of things like, okay, what's the square meter? How many rooms do you have? Where is the house located, and so on. And based on that data, you could try to predict, okay, what would the price be of that house? And there you try to predict a number. And the two, let's say, techniques for doing this is either classification or regression, right? The other thing that data science involves is doing segmentation or clustering. And that is, can we distinguish certain clusters in our data? And clusters mean that is data that is closely related to each other. Data that is looks similar in shape or in form or in data itself. Then we have anomaly or outlier detection. And that means, okay, are there certain data that is much different from all of the other data? Because we would like to separate that out, right? And last one is associate rule mining, and that means that, okay, what combinations of data do we see a lot? For example, this is used for market basket analysis. of supermarkets, for example, trying to see, okay, what kind of combinations of products do our customers buy in the shop, right? Okay, we already talked about large amounts of data. There is a lot of data, and big data is often distinguished by the 8 V's. And here you see the 8 V's, for example, what's the volume of the data? How large is it? What's the value of the data? But also the velocity, for example, which means, okay, how accurate or how valid is the data? Sometimes the data from yesterday is not so much worth today anymore. And sometimes the data keeps its value for, let's say, a year period. So that's a lot of differences there. And what we see is that we will have, we used to organize data in relational type of databases in the past, but now more and more we see the development of a lot of different unstructured type of data, like Twitter feeds, like videos, like pictures and so on. And they will, it's hard to put them in a relational type of database. So we put them in other type of databases called non-relational databases. And that's also a development that we see a lot. Okay, if you look at companies, here you see the development which is going on in companies when it comes to using data science or data analytics, because we used to look at data in the past and try to make our decisions based on it. And what we will see is that more and more companies are trying to automate these decisions. For example, if the weather turns from rainy into sunshine, then some online sites might want to, put their barbecue sets on the front page of their website. And that is not something that you want to do manually. No, because you've already learned from the data in the past that people are going to buy barbecue sets. So you want to automate those type of decisions. So what we see is that we will more and more move into predictive analytics and also prescriptive. So what can we do as a company, and can we automate those type of decisions? So that's the trend that we see nowadays. And also another trend is that we will talk Thursday or next week, we'll meet each other a little bit more in detail. So I know a little bit more of your background, but this is a little bit ICT related. But let's say in the 80s, companies started to collect the data that they want to take their decisions on in so-called data warehouses, and put dashboards on top of them in BI, for example, in an application called Power BI, for example, from Microsoft, that allows you to do dashboards, or Tableau, for example, that allows you to make dashboards. And what we see is that the data is getting, if you go to the right side here, the data is getting more unstructured and also real time. So what we see is the movement from data warehouse to what we call lake houses, where we have a lot of accurate data, and we will see a continuous monitoring and continuous machine learning in companies to base their decisions on. So these are the type of developments that we see in companies changing. So they are going to have data science and machine learning in the middle of their business processes rather than at the side, right?
Is that lake, is that like a small sea? Is that what they mean with lake? Or
lake is a large amount of data,
okay.
Unstructured, basically.
Okay.
Yeah. So we use different type of databases for that mostly. So these are a type of developments that we see when companies are implementing data science and machine learning into their business processes. Okay. When it comes to data science or AI, a more broad term, then we can also have a look at the hype cycle of artificial intelligence from Gartner. This is from 2022. And typically you see the hype cycle here that new developments, they first are hyped up and then they are at the top of their hype. And then expectations of this technology are dropping because, people think, okay, let's now implement it in reality and see what it can do. And then from that on, it will take a little bit more time before certain developments will mature. Yeah. So, for example, if you see here, computer vision, for example, that has matured out quite a lot already. And we have a number of open libraries already, where you can use computer vision techniques and machine learning. So that has evolved and has become more mature.
We see also in the engineering domain that a lot of times sensors are now being replaced by computer vision.
Right.
So
yes. So that's because it's already matured out.
Yeah.
And you have your OpenCV and all of your other libraries that can do these things already. Yeah. And then autonomous vehicles, that's something that's coming up now in maturity. Also deep learning, that's about neural networks. And then here you can see the natural language processing. And that's the ChatGPT type of development. So that will, I think, mature in the next couple of years more. And if you look around, let's say here, responsible AI, it's almost at the top here on the left side of the hype. And that is the development that companies more and more want to know, okay, if we have reached a certain decision with AI or machine learning, can we explain how this decision has evolved, or what's the background? Why does the machine learning algorithm choose this outcome? Yeah. So there are all kinds of techniques now in development where you try to explain what has happened and why the model has chosen a certain outcome. Okay. So that's AI. Well, if you want to do data science or AI, you can become a data scientist. And in order to become a data scientist, you should have a number of competences. And that starts with domain expertise. So trying to understand the business. I mean, if you're in engineering or if you're working for the Dutch railways, you should know, okay, how does it work here in this company with trains, with the different railroads and so on. So you should have your domain expertise. Ethics is something that's also important. We're not going to go into detail in this course in the ethical side of data, but there's obviously a lot of discussion about the ethical side of data science and artificial intelligence. And there's also some legislation going on in the European Union, specifically, for example, to look at face recognition and things like that, that is not allowed in the public space anymore for the coming years, and so on. So there's a lot more attention on this one.
Leonard, they know Leonard because he's like the learning team. I think he did his thesis on the ethics of AI.
Yeah,
that's real cool.
All right. So that's one part. That's the business or ethical side. Then obviously there's the programming or computer science side. If you want to do data science, you should know programming, should know how to handle data or handle databases. Then we have, let's say, more the mathematical side or statistics side. That's about statistic probability and also the machine learning, how that will work. And last but not least, you should be able, if you come to an outcome, you should be able to convince your management of what to do. And data visualization will help, and communication to within the company will help as well. So these are important parts of competences that any data scientist should have in order to be active in this field. Okay. So when we look at a report from a couple of years ago from the World Economic Forum, we can see that there's an increasing demand for data scientists or data analysts. On the left side, you can see jobs that are increasing, will be increasingly in demand for the coming years. And data scientists, analysts, and AI specialists are on the top, big data and so on. And on the right side, you see jobs that are decreasing in demand, like data entry clerks, administrative work, and so on, because that will partly be taken over by AI technology. Okay.
Is there teachers on the list also?
No, there's not.
Not yet. But
we are still, we are still, still needed, I guess, for the future. Yeah. Okay. Well, if you, I've did a quick query on data scientist positions or jobs in the Netherlands, and at the moment, 16,000 vacancies for data scientists in the Netherlands. So yeah, that means there's a lot of demand for data scientists. So if you want to be active in this field, there is a lot of opportunity at the moment with all kinds of companies. If you look here, Port of Rotterdam, I see Mercedes-Benz, I see McKinsey, etc. So,
and I think it's also a little bit like one-eyed in the land of the blind, right? I think
at the moment, yes. Yeah.
Even with this course, I think you probably can get a lot of those jobs already.
I think that this course will give you a good introduction in, let's say, what data science is about. That's correct, and that means that, yeah, if you apply for these type of jobs with the Master Next Level Engineering Master on your CV, that will help a lot. I guess.
Think so too.
Yeah. Okay. So next question is, okay, given all these developments in data science and so on, how do companies use machine learning or AI? And here is some of the use cases that we see typically for data science in different sectors like asset management or in healthcare. Obviously, diagnostics is something that we see a lot with the help of computer vision, for example. But also in manufacturing or transport, we see a lot of applications for AI.
But I was. Is it okay if I sometimes?
Yeah, sure.
Last week I was visiting Hogeschool Zeeland.
Yeah.
And you have an engineering thing. And I talked with somebody who worked on a thesis on they called it regenerative design. I think they used an AI tool to make the design, and the design really looked like the bones of a chicken, because that's like super mega. So he engineered the product, but he didn't draw one line himself. It was all done by the AI.
Yeah.
And it was pretty cool. It was really
yeah. So these types or let's say these type of generative type of neural networks will help a lot could help a lot in the design process.
I really think a revolution is coming, to be honest.
Yeah. Okay, this is some information from a recent report from McKinsey. Is okay, where do we see most AI or machine learning adoption? I will use the AI machine learning in between each other. It's what we mean is, let's say, all of the algorithm techniques that are used to let's say work with data and predict things. And here we can see that AI is already a lot being used in service operations. For example, in the chatbot area, there are a lot of sites that work with chatbots where you can ask your questions and so on. And these chatbots are getting better and better, especially with the help of ChatGPT type of solutions, obviously. But also in manufacturing, for example, here in the bottom, you can see predictive maintenance. That's something that is growing very rapidly as well. For example, at the Dutch Railways or at Tata Steel, they do a lot with predictive maintenance, trying to, based on sensor output, trying to predict when machines are going down or need replacement, etc., etc. Also in marketing and sales, we see a lot of use. For example, customer segmentation is something that a lot of companies do, and they use these machine learning techniques to do so. Okay.
I'm just uploading the picture I made last week.
Okay.
Of the design. But,
all right.
Okay.
Yeah. Here you see a list of typical AI capabilities that companies are using at the moment. So a lot of robotic process automation. That means that the programming part become less and less, and that you more or less click modules and flows together in order to create applications. Computer vision, as I said, is already in the maturity phase at the moment, so it's being used a lot by companies already, and so on. In the bottom, we see the generative adversarial networks and the transformers, transfer learning. That's the type of stuff that's coming up. And we will have a look at those one as well. I'm not sure if you will be able to program a generative adversarial network already for this course, but we will at least have a look at them and see how they are built and program them in Python. Okay? Okay, these data scientists, or if you become a data scientist, okay, there are a lot of tools available, obviously. So we've picked the most popular ones to do this. And there are all kinds of tools for data analysis, for data visualization, or the machine learning, the engineering, or development and operations in the cloud, or web development in general using AI. And more will come also. So there are a lot of tools. This is research from KD Nuggets, one of the, let's say, machine learning type of blogs that we see. This is from 2019, but it is still rather valid. Here you see the most popular software being used in this area for data science. Python is on top. You see also Excel, Anaconda, TensorFlow, Keras, and Scikit-learn. The ones that you see encircled are the ones that we are going to use in this course, okay? And if you look at the developments, the coding language, there was an article in The Economist saying that Python is coming up. You can see that here on the left side. The Python programming language is coming up very strongly. And instead, the Java language is going down. And you see that here in the most programming or most in-demand programming languages from vacancies here as well, that Python is on top. And so we're going to use Python, obviously. An alternative could be to use R, but we have deliberately chosen to use Python because that's growing a lot faster, and we see a lot of new libraries coming up in Python. I think that will be the winning coding language also for machine learning. And again, we see a lot of libraries available that we're also going to use in this course, okay? So then zooming in a little bit more into machine learning. So, okay, what is learning? What is machine learning? Well, again, a lot of companies are working with this. It's growing more and more. And yeah, it's hard to find companies, especially the larger ones that are not working with machine learning already. So what is machine learning? Well, it's about data, obviously, but it is about learning from data. What we try to do is to work with algorithms that can learn from that data without prescribing a model. So they will create a model from that data themselves. This model, if the computer can generate a model from the data, then we can use that model to predict things, okay? Or to cluster things, as you can see on the right-hand side. So to give you an idea how this works, well, you've all have some background already in programming. Normally what you do in traditional programming is that you define the rules yourself, because you write the programming, and if you do the programming, then you define the rules how you would like to handle certain input data. And then the application will give you your answers based on the rules. You put in the data, and based on those rules, it will produce answers, right? Well, machine learning works the other way around, because there we have the data, we have the answers, but what we are trying to find is the rules behind it. What are the rules making input data to output data? Yeah. To give you an example, let's say that we have this input data. So we have X input data and we have Y output data. Let's presume that we have a process where if we input a -1 into this process, it will generate an output of -3. If we input a 0, we'll generate a -1. If we input a 1, it will generate output 1. So again, here and here, right? So the question to you guys is, okay, what is the underlying rule here? So we have input data X, we have output data Y. What is the underlying rule here? Anyone?
Well, it goes higher every step you go. So with 1, it's the same. With 2, it's 1 extra. With 3, it's 2 extra. And with 4, it's 3 extra. So
That's correct.
what would be the exact rule? I don't know yet. Yeah.
Is there,
Something like times 2 minus 1.
Oh yeah. 2
Yeah.
times 6 minus 1.
Yeah.
That's correct. That's correct. So this is the underlying rule. So y is defined as 2 times x minus 1, right? It's a linear relation between the input and the output. Well, actually, the thinking that you just did is exactly what we see as machine learning. So that is what machine learning does, trying to find the, let's say, the rule behind the input and the output. So what is in between? And that is what machine learning does. So again, we had the input data that was minus 1, etc., the x values. We had our answers, we had output data, and the machine learning found the rule behind it, in this case, a very simple one, y is 2 times x minus 1. And this is what we call the model. So now we have a model, and this model is now being described by a very simple formula. But this is the model that we've created. And with this model now, we can do our predictions. For example, if we would put in a x value of 10, what would be the predicted outcome then? Anyone?
$19.
19, all right. Yes, we will generate 19. So based on the data there, the input and the output, we generate the model, and with this model, we can now use that model to predict, let's say, outputs given new data, because we haven't seen that 10 value yet. It's not part of your input data, it's new data, but based on the data on the left side, we created a model, and with the new data, we expect the outcome to be 19, right? So this is actually this is called linear regression. This is what you do when you do linear regression, basically. So there's one of the techniques which is part of machine learning. It's more statistical type of technique that will allow you to create your model. Okay, good. Then some other things that you should know. In machine learning, we are working with data tables. It's like n columns and m rows. We call that a data frame. And data frame is something that you will see in pandas. In pandas, we will work with data frames, and basically those are tables. And every column name is called a feature. So every data has a number of features. And every row in this table is called a data point or a record or a sample, right? And in most cases, we will work with tables. So if you want to do data science, you should collect data maybe from relational databases. And what you should do is to join all this data into one big table. That's the way that you're going to work. And then from this one big table, you can do your machine learning, right? There are other data structures, like for time series or spatial data structures or graphs or networks. But in most cases, in this case, we're going to work with data tables, and then the pandas library is being used to play around with columns and rows and so on. Okay. These features, if you see on the top, they can have different type of data, and that's very important because the machine learning needs to know what kind of data every column should have. So every column could be consisting of numeric values, like quantities, like years, kilometers, and so on. It could be values from a finite set. So like, for example, north, east, south, west, it's a finite set. And it has only 4 possible values, right? We call that a nominal type of feature. And we have a special case of nominal, which is called ordinal. And that's also important for machine learning. Is there a certain rank between these nominal values? For example, bad, sufficient, and good. Because if there is some sort of rank order, that is something that you want to take along in your machine learning. if one is better than the other, right? In north, east, south, and west type of columns, there is no let's say, rank order. So they are all equal. And that's important to know when you do machine learning. Okay, so this is an overview of all the different machine learning algorithms, and also the different, we're going to do all of these different algorithms, basically. So on the top part here, you see the more classical type of learning, and it is being split up between unsupervised learning and supervised learning. Bart will start in week 3 and week 4 with classification and regression. That's the most classical type of, let's say, machine learning. We will do some unsupervised learning like clustering and pattern search and dimensional reduction. That's unsupervised. I will tell you what the difference is between those two. And then in the bottom part, we have the more, let's say, neural network type of machine learning. And there we have things like convolutional neural networks, recurrent neural networks, degenerative networks, and autoencoders, and the basic perceptual networks. We will also zoom in, I think, in week 6 and week 7 into how to build these neural networks and how to use those to do your predictions or recognitions. Okay? So there are a lot of algorithms, and most of them we are going to go through in this course. So in this case, there's a lot of ground that we are trying to cover here. Okay? So what is then the difference? You can see here on the top, we have supervised and unsupervised learning. So what is the difference? Well, supervised learning is that we have certain features. I told you about these tables, that we have different features. Those are the columns. There's one feature in it that we can use as a target feature or a label. For example, we have pictures of cats and dogs, for example. And we know that it is a picture of a cat. We can feed it into machine, and we can create, we have a data set. And then with supervised learning, we can try to make or to distinguish between a cat category in pictures and a not cat or a dog category of pictures. And so with supervised learning, we have data which is labeled. And labeling means that we know it's a picture of a cat or we know it's a picture of a dog. And by feeding in a lot of pictures, we can have the machine or the algorithm learn from that data. And that means that if we put in a new picture, then the machine would be able to distinguish between it's a picture of a cat or it's a picture of a dog, for example. Typical techniques are classification and regression for supervised learning, right? Then unsupervised learning is where we don't have labels. So we don't know what the pictures mean, for example, or we don't know what the data means. And the only thing that we're trying to do is separate out all of the data into certain groups, for example, and try to find out, okay, pictures that are almost identical, we put them in one group, and pictures that are different, we put them in another group. So can we have the algorithm distinguish between certain types of data when we do not know what the pictures means, but can we create clusters, for example?
And it could have been that the machine then saw a model like standing ears and hanging ears, right? Because you don't know which groups it's going to make, right?
That's correct. Yeah. And for example, in marketing and sales, this is used, for example, where you put in your customers and you know, okay, how much they have spent, for example, and where they have spent their money, and what kind of products they have bought. And then you want to cluster those customers. For example, in one group, you have people that have spent more than 1,000 euros a year. And in the other group, you have people that spend less than 1,000 euros a year, or people that have bought certain products. You can make customer segments out of those, right?
This is also a concept I think they had with complexity science, that you've got valleys. Like
Right.
you've got people who buy sport cars, basically red cars, blah, 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 blah.
Right. Yeah. So typically you do this when we do clustering or anomaly detection. So we try to spot maybe some data that is quite different from all of the other data. Yeah. Okay. Then, we are also going to look at neural networks and deep learning. So what is then deep learning? Well, basically, we can use so-called neural networks to try to learn from data. And what is a neural network? Well, you can see it over here. This is an example of a neural network. And each neural network has a vertical layer of input neurons, as you can see over here. That's the left layer. And it has an output layer, you can see on the right-hand side. And in between, we can have no hidden layers, or we can have a lot of hidden layers. And the more layers you have in between, the deeper this network is, and that is where the term deep learning is coming from. Deep means that we use a model that has a lot of hidden layers, deeper layers, so to speak, into the network. And the idea of a neural network is to put in a lot of data through this network in order to, let's say, define weights of communication between these layers of neurons in such a way that if you put in a certain picture, for example, or certain data, that it will generate a certain output, for example, to recognize certain pictures. And I will explain you later on how this works, but let's imagine you have handwritten pictures, and we have pictures of 28 by 28 pixels. In this case, we have 784 pixels in total, and every pixel has a value between 0 and 1, indicating the gray value. 0 means black, and 1 means white, right? So what we need here, if we want to recognize handwritten digits, what we need here is that we can put in 784 pixels into a neural network, and this neural network should output 10 possible values, because it could be a 0, it could be a 1, etc., up until 9. So there are 10 possible output values. So this could be a typical neural network that you see over here that is able to recognize handwritten digits from pictures of 28 by 28 pixels, in total 784 pixels. And the idea is, if you, for example, put in a handwritten 7, then it will flow through the network, and then the idea is that the 7 neuron in the output layer will blink up, indicating that the picture that you have put into the network is indeed a handwritten 7. Well, how this will work and how this network is trained, we will explain you that later on when we talk about the neural networks. But this is the basic idea. So, in fact, this is one gigantic memory which is trained and which is, let's say, set to be able to recognize these handwritten digits. Okay?
I have a question. So what would be so you have a hidden layer. So does it have like one rule? So it only looks at the, if it has one curve on the upside, for example, then it's either a 2 or a 3 or a 6 or 8 or 9, and then it filters out some numbers already, or?
Well, basically what it does, but again, this is a quite complex area. I will tell you a lot more about it later on, but basically what happens at a, let's say, one specific neuron here in a hidden layer is it will take the input from all of the neurons from the layer before it, on the left side, and it will then apply a so-called activation function on it, and then it will output its value to all of the neurons in the layer behind it. And by defining the weights of all of these connections between, let's say, this input layer and a certain neuron here in between, you will define how much of the signal from, in this case, a certain pixel will come into this neuron. And also this neuron will then fire the same value to all of these other neurons in the next layer. Yeah. And these in turn will then also apply a certain function to it. And by tweaking the weights of all these connections you see over here, all these white lines, you build up a large memory, more or less, you could say. Such that when you indeed input a handwritten digit here, then it will fire the right type of connections and values, and it will lead to a, let's say, a 1 at this output neuron and zeros at the other output neurons, for example.
Yeah, but Alexander, you basically don't know what is in that information. What Johan is telling is absolutely true, but you don't know yet, does that mean that it's curved, or you don't know? It's basically a little bit a black box, right? You don't know what.
Well, I will show you a simple neural network when we are at week 6, where I've put in, let's say, a dice with 6 values 1 to 6, and then we will look at the values of the weights of all of the connections. It's a rather simple network, and then you can see how the network really tries to identify groups of recognitions, and then you can see what's going inside. But in most cases, we do not exactly know what's inside such a network. We only know how good it is in recognizing handwritten digits because we can measure that.
This is also why the ethics a little bit comes in, Alexander.
Yeah, that's why in the beginning I told you about the hype cycle. That's why we need, companies more and more would like to afterwards try to explain, okay, why has this decision has taken place and being taken? What goes on? What's the rationale behind this certain decision, right? So, but okay, we'll come back to that one. So what can you do with machine learning then? Well, you've all used it, obviously, a lot of times yourself. For example, if you're onto Netflix, you will get your recommendations. If you've seen certain movies, you will get recommendations for other movies. You could use it for computer vision in cars, for example, in detecting if the driver is sleeping or not by looking at the eyes and the movements of the head, for example, and giving signals to in the car to the driver to pay attention, for example. You could use it to detect cancer. So this is a column. And then the computer already indicates with these squares, either green or red, if certain areas might be suspicious or not. Yeah. You could use it to do credit card fraud. That's outlier detection. Do we see certain transactions that are quite different from other transactions? You could use it for doing computer vision on railroads. For example, a company here in the Netherlands, Volker Wessels, and I hope to have one of our guest speakers from Asset Insight that is doing this. They have a lock. It's called a Sure lock, driving around the Dutch railway, taking pictures from the railroads, and then with machine learning, they try to see if there are any cracks or other problems with the railroad, so they can detect it live, right? Here is an example where you can distinguish between, let's say, weeds, different types of weeds, and you can spray very precisely your herbicides at each square centimeter. In trying to, very specifically put in your herbicides at the right place. And that will save you around 80 to 90% on herbicides like Roundup and so on, obviously. So it will help a lot. So you have a lot of cameras hanging there underneath that actually do this detection of weeds, right? This is another example in the Dutch market, a company called Connectera. They use sensors on the neck of a cow, and they, based on that, they can distinguish the certain moves from cows. What do they do? Are they grooming? Are they eating? Are they resting, etc.? So they can, with that one, they can predict the health of a cow, for example. SpaceX is using it for having these rockets land at the right places with AI, for example. Obviously, you have your self-driving cars. This is images from Tesla trying to recognize the objects on the road and taking the right measurements in the car to actually drive safely on that road. Here you can see that it actually can detect bikers and people on the road and so on, actually detect the trends and so on. But we see more and more applications where we have generative, so-called generative machine learning, like deep art effects. There you can upload an image, for example, of our entrance here at the Hogeschool Utrecht. And you say, okay, can we transfer that image, this one, can we transfer it into the style of Van Gogh? And if you do so, you get this picture, right? So it's called style transfer. And in order to do that, we use generative machine learning networks. I will show you later on how this works. Also, a typical example where you can use old pictures to actually create videos from already past people that have passed away, so you can bring them to life, right? So that's and obviously ChatGPT, and we will talk about that later on. And given the time, because we should already finish up in a couple of minutes.
Yeah, we have to discuss the homework, I think, right?
Yes. So I can show it later on. I've asked ChatGPT, okay, why should somebody learn data science? We can have a look at it, what the answer will be, but he will say it later on. I've actually asked ChatGPT to do some, making a Python program that can output certain numbers. It will do so. So it can also help you with the Python programming.
Some of the students did it already for engineering fundamentals.
Sure. So we'll see how that works and what you can do with it. Okay, I will skip this one. There are a lot of things going on in this area. There are some books that you can read to see, okay, what do companies do already with artificial intelligence and machine learning. I will skip this one. Again, we are not going to handle ethics in detail in this course, but obviously there's a lot of things to be discussed here about the ethical quality of the predictions and outcomes and effect on humans and so on. There's a lot of material here. Okay, to finish off, on Thursday, I will tell you more about the different tools. I will tell you a little bit more also about different group assignments and possible topics and so on. In the meantime, I would ask you to install Spyder if you've done, probably you already have done so. Also try to install Google Colab. Yeah, that would be good. And also try to install Chrome extension, the webscraper.io. You will find information in the Chrome extension part, and then try to install it, because I'm going to demo it now on Thursday, and that tool might come in handy when you're trying to collect data that you need for your group assignment, right? And last but not least, try to form some group. We're looking for 3 to 4 students for every group. I think we have 16 students in total. So I'm thinking about 4 groups of 4 students each, or 5 groups. So think about the students that you would like to work with in a group, and think about a possible group assignment. And I will give some examples again on Thursday. Okay, so far for our first introduction lesson about data science and its applications and about this course. Are there any questions or anything that you would like to add?